All right, so now we're going to talk about inscribed angles of circles. Okay, so let's start with the definition. So an inscribed angle of a circle is an angle whose vertex is on the circle and whose sides contain chords of the circle. Okay, so we have a bunch of different cases here of types of inscribed angles that you could see. Okay, so in general, angle ABC is an inscribed angle that intersects arc AC. So notice that BA and BC rays that form the angle containing chords BA and BC. Okay, so these are chords of the circle. This is the inscribed angle, and it's kind of like on the opposite side of the circle of the arc that it intercepts. Okay, so the first case of an inscribed circle, one type of angle you can see is the center of the circle is contained in one ray of ABC. Okay, so BC is going to be the diameter because circle O, point O is the center. Okay, and BA is a chord, and BC, well, BC is also a chord, but it's also a diameter. All right. Another case is you can see is the center of the circle is in the interior of angle ABC. Okay, so this is the center of the circle, and as you can see, this is the diameter, and it's obviously like inside the angle we have here. Okay, and then another case, the center of the circle is in the exterior of angle ABC. So the center of the circle is not even has nothing to do with this angle, and yeah. All right, so the rays don't contain the diameter, or the diameter isn't inside the angle. It's on the outside of the inscribed angle. Okay. Now, the next thing we're going to talk about is the measure of an inscribed angle of a circle is equal to 1/2 the measure of its intercepted arc. Okay. So the inscribed angle is equal to 1/2 of the arc it intercepts. Okay. So let's go back up and use a circle right here. So in this case, the measure of angle ABC is equal to 1/2 of the measure of arc AC. Okay. So for example, if the measure of arc AC was, say, 40, then the measure of angle ABC is 20, because that is 1/2 of 40. Okay. All right, so let's look down here. So an angle inscribed in a semicircle is a right angle. Okay. Now let's talk about why. A semicircle is half a circle, and a full circle is 360. So if this is a half a circle, then the measure of this arc is 180. Okay. Now, this is the inscribed angle that intercepts this arc here. Okay. So if you take your fingers, whatever, and you put at the angle and you go down the rays, you can see that this is the ABC is the angle that intercepts this arc. Okay. Now, if this arc measures 180 degrees, then obviously this angle is going to equal half that. So it's 90 degrees. Okay. All right, so let's go to the next page and look at this one. Okay, so now we have two inscribed angles of a circle that intercept the same arc are congruent. Okay, now I'm going to separate these two angles. I'm going to draw two different diagrams so you can see this a little better. So it's easier to see this. Okay, so I'm going to draw angle ABC, inscribed angle ABC. And I'm going to draw inscribed angle DCA. Okay. Now, if we take a look at this one, we have angle B here, and angle B intercepts arc AC. Okay. Now, same thing with angle D though. Angle D, angle ADC intercepts arc AC. Okay. So now, since they intercept the same arc, angle inscribed angle ABC is going to be congruent to inscribed angle CDA because they both intercept arc AC. Okay. All right, so let's do some example problems with this inscribed angles. Okay, so let's take a look at the first one. So you first want to find the measure of an inscribed angle that intercepts an arc whose degree measure is this. So we are first given the measure of the arc is 60. So let's draw a little diagram. Okay. And we want to find an inscribed angle. So it's going to be on the vertex is going to be on the circle. And the arc measure is 60 degrees. Now, remember, the measure of the angle is inscribed angle is equal to half the measure of the intercepted arc. Okay. So if my intercepted arc is 60 degrees, 1/2 of 60 is 30. Okay, so the measure of this inscribed angle is 30 degrees. All right, so same thing with letter D. So we are given the measure of the arc to be 75, and we want to find the measure of the inscribed angle. Okay, so same rules apply here. You want to take half the measure of the arc, which is the measure of the arc is 75. Now, half of 75 is 37.5. So the measure of this inscribed angle is 37.5 degrees. Okay. All right, so now we want to find the degree measure of an arc intercepted by an inscribed angle. Okay, so we are given the inscribed angle. We want to find the measure of the arc. Okay, so now it's kind of opposite of a rule here. The arc, the measure of the arc, is equal to twice the measure of the inscribed angle. Okay, sorry, this is inscribed. It's hard to see that, but it's in this word is inscribed angle. Okay, so let's draw a diagram. So our inscribed angle is 60 degrees. Now, since the intercepted arc is twice the measure of the inscribed angle, and our inscribed angle is 60, we're going to do 2 times 60. So 2 times 60 is 120. So the measure of this arc is 120. Okay. All right, so our next one, we are given an inscribed angle with the measure 90. Okay, so this is our rule that we had on the last page. If we have an inscribed angle that is 90, then our arc measure is 180 degrees, right? Because if 90 times 2 is 180. Okay, so this is going to be a semicircle, semi-arc, with a degree measure of 180. Okay. All right, so let's look at 3. So we have triangle ABC is inscribed in a circle with the measure of angle A is equal to 80, and the measure of arc AC is equal to 88. Okay, so we want to find the measures of a few different things. All right, so let's first talk about the measure of arc BC. Okay, so now the arc BC is intercepted by angle A. Okay, actually, I'm going to redraw this diagram with only this angle. So B, C, A. So if this is 80, Now remember, the arc that's intercepted is twice the length, twice the measure of the inscribed angle. Okay, so in this case, since we're finding the arc, so the measure of the arc is equal to twice the measure of the inscribed angle. Okay. Now our inscribed angle is 80, so we're going to do 2 times 80, which is 160. So the measure of arc BC is equal to 160 degrees. Okay. So this arc here is 160 degrees. Okay. All right, let's find the measure of angle B. So this is angle B here. Okay. Now, the measure of angle B intercepts arc AC. So I'm actually going to redraw this so we could see this. So the arc AC is 88. So now, since we are given the measure of the arc, we're going to use this rule right here. Okay, so remember, the measure of the inscribed angle is equal to half the measure of the arc. Okay, so the measure of angle B is equal to half of 88, which is just 44. Okay, so the measure of angle B is 44. Okay, that's 44. That's 44. Okay. All right, so now we want to find the measure of angle C. Now, we have to be careful with this one. Okay, so angle C intercepts arc AB. Now, we don't know arc AB. Okay, there's no value there for us, so we have to somehow find it. Now, remember, so we have at this one and this one. Now, remember, there are 360 degrees total in the circle. Okay, so to find AB, we can add these two, the measure of these two arcs, and subtract it from 360. Okay, so let's do 88. I'm just gonna 88 plus 160. So let's do 88 plus 160. So 88 plus 160. Which is 248. And then we need to do 360 minus 248. So 360 minus 248, which gives me 112. So the measure of arc AB is 112. Okay. Now, the measure of C, remember, is half of this arc. So the measure of angle C is half of the measure of arc AB. So the measure of arc AB is equal to 112. So half of this is 56. So the measure of angle C is equal to 56. All right, now I kind of got ahead of myself here. Now they want us to find the measure of arc AB. We just did this. It's the measure of arc AB equals 112. Okay. But let's say if you did not know how to find arc AB first, let's take a look at this. This is a triangle. And remember, all the angles in a triangle add up to 180. So theoretically, you could have added 180 plus 44 and then subtracted that from 180 to get 56. Okay. So there's just a couple different ways of thinking about it. So let's go on to the next page and let's do some examples, some more examples. Okay. All right, so now we have if AB is parallel to DC and the measure of angle B is 36, we want to find all of these measures, okay? So we were given AB is parallel to DC, okay? So these lines, this is parallel to this. And the measure of angle B is 36, okay? So now we want to first find the measure of angle D. Now, remember what kind of angles are formed with parallel lines. Okay, remember alternate interior angles can be formed with parallel lines. So this angle and this angle are actually congruent. So the measure of angle D is equal to 36 as well. Okay. All right, so now we want to find the measure of arc AD. Now, the measure of arc AD is intercepted by angle ABD. So I'm going to redraw this. It may be helpful for you guys to redraw your diagrams when you have multiple angles like this, just so you can see clearly which angles are intercepting which arcs and kind of whatnot. It may be just easier to see. It's an extra step, I understand, but like I said, it may be easier for you to see. So the measure of AD is twice the measure of this inscribed angle, okay? So remember, the measure of our inscribed angles is equal to half the measure of our arcs. Okay? Or vice versa, 2 times the angle is equal to the arc. So in this case, we have an angle. So the arc is twice the measure of this angle. So 2 times 36 is equal to 72. Okay, so the measure of arc AD is equal to 72 degrees. Okay. Now we want to find the measure of arc BC. Okay. Now here's the thing. I'm going to stop us for a second, and I have a new rule for us. New little circle rule, so you guys can go ahead and actually get out your reference sheets or circle of reference sheets, okay, to find this rule. Okay, so I'm going to get out my circle reference sheet. Okay, so if I have 2 parallel lines like we do in this diagram, so if we were given AB is parallel to DC, then arc AD, that's a bad color to use on this piece of paper, but arc AD is going to be congruent to BC. Okay, so parallel chords intercept congruent arcs. Okay, so if AB is parallel to DC, then arc AD is congruent to BC. Okay, so parallel chords intercept congruent arcs. I'm going to give you a minute to write before I pull it away. While we're at it too, let's write down our inscribed angle rule. So here's my inscribed angle. So the angle X is equal to 1/2 the measure of arc AB. Okay. And then actually one more. So remember our right angle, if an angle that is inscribed in a semicircle equals 90. So we have a semicircle, so an angle that is inscribed in a semicircle equals 90 degrees. Okay, because a semicircle is half a circle, and a half a circle measures 180, so half the measure of the arc is 90, so this is a right angle. Okay. All right, so let's go back to the note. Sorry, got off a little track there. All right, so let's go back to our notes. So we were trying to find the measure of arc BC. Now remember our rule. If we have two parallel lines, two lines are parallel, then this arc is congruent to this arc. Parallel lines intercept congruent chords, okay? So if arc AD is 72, then this is 72 as well. Okay, so the measure of arc BC is equal to 72. Okay, so now we want to find the measure of angle A. Now, again, I'm going to redraw this diagram. So we only have angle CAB in here. Now, arc CB is 72. Okay, so remember our rule. Our inscribed angle is half the measure of the arc. So if arc CB is intercepted by the measure of CAB, so the measure of angle A is half the measure of arc CB, or BC. Now, BC is 72, so the measure of angle A is 1/2 of 72. So the measure of angle A is equal to 36. Okay. So it's the same as the measure of angle D, which is 36, and the measure of angle B, which was 36. Okay. Now we want to find the measure of angle C. Now, since we know that these lines are parallel, this angle and this angle are alternate interior angles. So if this angle is 36, then this angle is 36. Okay, so the measure of angle C is equal to 36 degrees. All right, so let's go on to the next example. All right, so we have diameter DOE is perpendicular to chord AB at F. So perpendicular at F, so this creates a right angle here. Okay, so AOC is a diameter and BC is a chord of circle O. Okay, so if arc BC is 60, then we want to find a whole bunch of these. So arc BC is 60, so we know this to be 60. All right, so let's start with arc AB, I guess. So if AOC is a diameter, so if AOC is a diameter, then this whole arc ADC, is 180 degrees. And this whole arc is also 180 degrees. Okay. Now, we know this little part to be 60. So the rest of this arc AB, the one we want to find, is equal to 180 minus 60. Okay. So the measure of arc AB is equal to, like I just said, the measure of arc ADC minus the measure of arc BC. Now, since ADC, like I said again, is 180, so 180 minus the measure of arc BC is 60, then the measure of arc AB is 120. Okay, it's just 180 minus 60. So this whole thing is 120. Now, we want to find the measure of angle A. Now, the measure of angle A is intercepts arc BC. Okay, so I'm going to redraw this so we can see it. Now, we were told that arc BC is 60. So remember, inscribed angles are half their intercepted arc. So the measure of angle A is equal to half the measure of arc BC. Okay, so if BC is 60, then half of that's 30. So the measure of angle A is equal to 30. Okay. So this is 30 here. All right, now we want to find the measure of angle C. So angle C is here. Okay, I want to redraw this. So we have angle C, and then there's like a little chord right here. I don't know if you can tell, but that goes up to B. So B is here, C is here. Now the arc angle C intercepts arc AB. Okay, now we know AB to be 120. That's what we found. Okay, so now again, the measure of our inscribed angle C is equal to half its intercepted arc, which is AB. Now AB, like we just said, is 20. So 1/2 of 120 is 60. So the measure of angle C is equal to 60. So this is 60 here. Okay. So now we want to find the measure of arc AD. Okay. So this is arc AD here. Now we don't have, AD is not intercepted by an inscribed angle, but it is intercepted by a central angle. Okay, angle AOD. Now let's think about this. We were told that diameter DOE is perpendicular to this chord. Okay, so there's a bunch of right angles. So this is the arc we want to find. So now remember from our first lesson, the arc is equal, the measure of the arc is equal to its central angle. Okay, now since this is the vertex is the center of the circle, this is a central angle. Now this is a 90-degree angle, and this is a 30-degree angle. This is a little triangle right here, right? So the angles in that little triangle add up to 180. So if we find the measure of this central angle, we can find the measure of this arc. Okay, so the measure of the central angle is 60, because 120 and then 180 minus 120 is 60. So the measure of this is 60. So remember, the arc is equal to its the measure of the central angle. So since this is 60, this is 60. So the measure of arc AD is equal to 60. Okay. Sometimes we're going to have to like take a couple steps and think a little bit. Now that was arc AD. Now we have to find the measure of AOD, which we just did. We got it a little ahead of ourselves here. But the measure of angle AOD is equal to 60. Now we want to find the measure of arc CE. Okay. Now, CE, this doesn't have an inscribed angle that intercepts this arc, but it does have a central angle that intercepts this arc. Okay. Now, since this central angle, which is 60, which we just found, and this angle are vertical angles, they are the same. So if this is 60, this is also 60. So and remember our rule, the measure of our central angle is equal to its intercepted arc. So if this central angle is 60, then this arc is 60 degrees. So the measure of arc CE is equal to 60 degrees. Okay. All right, so we have just a little bit left. So we have one more example. So let's go ahead and look at that example. Okay. So this one, we have to draw a diagram. So if triangle ABC is inscribed in a circle, okay, so we have circle, and if it's inscribed, then the angles are on the circle. So we have angle A, B, C. Okay. Now, the measure of arc AB now we have like a ratio thing. So the measure of arc AB to the measure of arc BC to the measure of arc CA is in ratio 2, 3, 4. Okay. So remember, when you guys just see these numbers, remember just put an X at the end. So AB is 2X since that's first, right? So the measure of arc AB has that too. So this is 2X. Arc BC has 3. So 3X. And the measure of arc CA is 4. So this is 4X. Okay. Now, first of all, before we can even go about finding these, we first have to find what X is equal to so we can find the measure of these arcs. Now, remember, there are 360 degrees in a circle, in a rotation of a circle. So we're going to add all of these up and set it equal to 360. So we are going to do, let's do it down here, 4X plus 2X plus 3X is equal to 360. Okay. So now we just solve for X. So this is 9X. So X is equal to 40. Now to find the measure, we just go back and plug in X. We just plug in 40 for X. So 4 times 40 is 160. So the measure of this arc is 160. 2 times 40 is 80. So the measure of this arc is 80. 3 times 40 is 120. So the measure of this arc is 120. Okay. So now we know the measure of the arcs. Now we can answer these questions. So we just answered the first 3. So the measure of arc AB is this one, which is 80. So the measure of arc AB is equal to 80. Okay. The measure of arc BC is this one, which is 120. So the measure of arc BC is equal to 120. And the measure of angle, the measure of arc 8CA is this one. So measure of arc CA is equal to 160. Okay. All right, so now we want to find the inscribed angles, the measure of the inscribed angles. So remember our rule, the measure of our angles is equal to half arc. Okay. So let's start with A. So if we take our fingers, we can see, start at A, we can see that BC, angle A intercepts arc BC. So it's half the measure of arc BC. So it's 120. So the measure of angle A is equal to half of 120. So half of 120 is 60. So the measure of angle A is equal to 60. Okay. Now the measure of angle B, same thing. Measure of angle B is intercepts arc AC. Arc AC is 160. So the measure of angle B is half of 160. Half of 160 is 80. So the measure of angle B is equal to 80. And last but not least, the measure of angle C. The measure of angle C intercepts arc AB, which is 80 degrees. So the measure of angle C is equal to half of 80. So the measure of angle C is equal to 40. Okay. So that is lesson 3.